Hey guys, so today we are going to discuss about the question called as smallest number in infinite set. So this is a lead code medium question. This is actually a new question, so that's the reason why there are less likes and less dislikes. So as there are more likes than when compared to dislikes, so it's a good thing. So yeah, let's start reading the question. So you have a set which contains all positive integers. So what they're trying to say is you are having some integers like a set which are positive, so till infinity. So let's say they are like 1 2 3 4 5 and so on till infinity, right? So implement a class called as smallest infinite set. So you have to implement a class called smallest infinite set, and that infinite set class contains some functionalities, so you have to implement those functionalities. So one of them would be constructor. So constructor, like if you want to perform some initialization something, then you can write the logic related to that in that constructor. So the other main two methods which you have to implement is pop smallest. So this pop smallest, it is a method which returns an integer. So what it does is it returns and removes the smallest integer from the infinite set. So for example, let's say we have called this pop smallest. So it might be like this, like let's say pop and smallest. So as we have said before, this returns the smallest integer, right? So in this case the smallest integer would be 1, right? So I have to remove 1 from the set and return this 1. So now the another method would be add back, right? So this add back will pass an integer. So I have to take this number, and if at all this number is not there in this set, then I have to add it. For example, let's say this number is 1. Let's assume. So as 1 is not there in the set, right? So what I can do is I can just add this 1 to the set, then that's it. So this is what add back does. So these are the functionalities of this smallest infinite set class. So let's try to find out how can we technically solve this, how can we technically implement this. Let's try to take the given example itself, example 1, and let's try to find out how can we get this output. So as we have discussed before, so we have two methods, right? One is pop smallest and one is add back. So pop smallest will return the smallest one, add back will add the number back to the set. So let's try to find how can we how can we implement this. So as the requirements are, we have to find the smallest one, right? So for keeping track of that, what I'll be doing is I'll maybe we keep a variable something like that call as smallest. So I'll keep track of the smallest integers with this smallest variable. And as we're having infinite number of integers, right? So we cannot store this, and if we want to remove something, we cannot remove that number from there because this is infinite, it might be anything. So what we can do is, instead of storing this infinite numbers, what we can do is we can store the removed numbers, right? So that would be the better case. So what I can do is I can maybe like I can create a set called as removed numbers, and I can store the removed integers in this. This would be the better case, right? So this will store the removed numbers. So let's start the input. Let's check the given input itself. And so in the given input, the first one would be add back of 2, right? So first things first, let's initialize the smallest variable. So generally in the infinite set, at the beginning the smallest number would be 1 for sure, because these are all the positive integers, right? So the smallest positive integer would be 1, so this would be 1. So we haven't removed anything yet, right? So the set would be empty. So the first call which is happening is add back of 2, which actually means we have to add 2 back to the set if at all it is not present. So as we haven't removed anything, so we can check in this removed set. So if 2 is there in this removed set, then that actually means we have removed 2, so we can add 2. So in this case 2 is not there in this removed set, right? That actually means we haven't removed 2. 2 is already there in this set, so that actually means we don't have to do anything, so we can just return from this function. So the next method call would be pop smallest. So as we have seen, this will return the smallest number in this infinite set. So in this case the smallest number is 1, right? So I will return 1, and I have to keep track of the next smallest one. So what I can do is I can just do smallest plus plus, so this will become 2 in this case. And the main important thing is, what if this next number is removed from the list? It might be a case, right? So that's the reason what I can do is I can use a while loop while smallest while smallest is in removed, then I can have to implement this till it is not there in this removed, right? Because I have to make sure that the smallest one shouldn't be in this removed set. If it is there in this removed set, that actually means that number is not there in this infinite set as well. So I have to increment till the smallest variable till that is valid, that is there inside this set. So in this case, I have incremented the 1, it is 2, 2 is not there in this, right? So I can just make this as 2. And most important thing, as we have popped smallest one, which is 1, I have to add 1 to this removed set. So let's continue. So the next call would be pop smallest. So the next smallest one would be 2, right? So we have kept track of that as well. So the next smallest one would be 2, and I have to increment the 2 to 3, and I have to make sure 3 is not there in this removed set. As 3 is not there, I can just put 3 as the smallest one, and as we have removed the 2 from the list, I have to add this 2 in the removed set. So the next call would be again this pop smallest one only. So pop smallest, so this is going to be 3, right? Because the smallest one is 3, so the current smallest one is 3. I have returned the smallest one, so I have to increment the next smallest. I have to increment the smallest to find the next one. So I have incremented it to 4, so the small plus plus would be 4, so this will become 4. So I have to add 3 as well in the removed set because we have removed 3. So now the next call would be add back of 1. So this seems interesting now. So add back of 1, right? Which actually means we have to add back 1 to the infinite set if at all 1 is not there in the infinite set. So how can we verify that? By saying this removed set, right? So if the number is there in this removed set, that actually means we have removed from the infinite set. So as this 1 is there in this removed set, right? What I can do is I can remove the number from the removed set and add to the infinite set. And main important thing is I have to verify whether the new added number is smaller than the current smallest number. So in this case, as we have added 1 is smaller than the current smallest number 4, right? So I have to change the smallest number to 1. So this is the main important case in this add back. So add back doesn't return anything, right? We don't have to return anything. So the next call would be pop smallest, and as we know, this will return the smallest one, right? So now in this case, the smallest one would be 1. So this is 1, so I have to return 1, and I have to increment the smallest one so that I can get the next smallest number. So I have incremented this 1 to 2, so I have to verify 2 is there in this removed or not. If 2 is there in this removed, that actually means that is not there in this infinite set. So as 2 is there, I have to increment till I don't find any number in this removed. So 2 is there, and 3 is there, and 4 is not there, right? So I have to make this to 4. So this would be 4. So again, pop smallest, so this will return the smallest one. So current smallest one is 4. I have to remove the smallest one, I mean the one which is the smallest, add this to 4, I mean in the removed set. So now the next smallest one would be 5, right? So now again pop smallest, so this would remove the smallest one, which would be 5, and add 5 to this removed set. The next smallest would be 6. So I think we are done with the given input, right? So this is the given input, and these are the outputs for the respective method calls. So this is how you find technically, like how do we use the removed set and how do we keep track of the smallest number and find out how, like the smallest number in the infinite set. So let's try to implement this code. So here we are having a class called as smallest infinite set. So as we have seen before, we have to implement this class, right? So it has a constructor, it has a method called as pop smallest, it has a method called as add back. So let's start with the initializations. So as the requirements are a removed set, right? A set which we can store the removed elements, and a variable called as smallest where we can keep track of the smallest number. So let's start initializing them. So I'll be using a hash set. So this would store integers in it, and I can rename it as removed, and I can name a variable called as smallest. It will keep track of the smallest integer. So removed would be a hash set, and initially smallest number would be 0. Anyhow, the if you don't initialize also it would be 0, but just for clarification the smallest number would be 0. So what I can do is let's name it as 1, because we are dealing with the positive integers, right? So initially smallest would be 1. So now let's start to implement the pop smallest one, right? So first things first, if at all we got a method call of pop smallest, the answer would definitely be the one which is there in the smallest variable, right? So let's store that, because we also have to perform some things after getting the smallest one as well. So the answer would be the current smallest one, and what I have to do is I have to add the value to the removed set, right? So removed dot add the smallest one. So this will add in the set, so that, which actually means we have removed the smallest number from the infinite set. So now I have to make sure I have to keep track of the next smallest one. So first thing I'll be incrementing the smallest variable, and now I have to make sure the smallest one is not there in this removed list. So if it is there in the removed list, I have to just keep on incrementing the smallest variable. So I can use a while loop. While removed dot contains the smallest number, just keep on incrementing till it is not there, right? So if it is not there, that actually means that hasn't been removed, right? So I can use that as the smallest number. So at the end the smallest number will be stored in this only, and I can just return the answer. So this is the implementation of the pop smallest method. So let's implement the add back. So first things first, what this add back method does, it will add the integer to the infinite set if at all it is not there, right? So we have to check that whether it is there or not. So how can we check that? By using the removed set, right? So if removed set doesn't contain this number, that actually means it is already there in the infinite set, right? So we don't have to do anything, just return. So if it is there, then we have to perform. So first things first, what we have to do is, if it is there, we have to remove it from that set, because we're adding it back. Remove dot remove the number which is given, and also what if this given number is smaller than the current smallest number, right? For example, let's say the current smallest number is 4, and if the given number which we need to add back is 1, so in this case 1 is smaller than 4, right? So I have to change the smallest number. So if num is less than smallest, then smallest will become this num. So this is it. So this is how you implement add back method as well. So this is pretty much the implementation. Let's try to run this. Yeah, it got accepted. So yeah, I think there is only one test case, right? So let's submit this. Yeah, it got succeeded. So this is pretty straightforward solution. So this is how you find the smallest number in infinite set. So if you like the video, please make sure you like and subscribe. Thank you.